the biggest challenges we face, and you probably got a hint of it on some of Jason's slide, is the number of acronyms that come our way. And even within the CBTN, it's sometimes a challenge for us to say, what's the relationship between Kids First, CBTN, where is CBTN's data? And so I wanted to just give you a brief framing before the next introduction, sort of to build a narrative. This meeting is a bit of an expo, right? It's an intersection between scientific talks, initiatives in ways that I hope you leave, with a thread connecting the two. So you heard from Roland and AWS, about large-scale global infrastructure to support the next wave of discovery. Just heard from James, right? A national infrastructure that's being built on behalf of pediatric research. Let me pull a couple of threads before I hand it off to Vincent. James highlighted that today, if anybody in the world, right, requested CBTN data, right, they could get access to it in a day. That's unprecedented for any one of you who has ever tried to get data from any other institution. It's not. There are two components to the unprecedented part. One is the legal, contractual component. The second is historically the movement of data and transfer of data. Turns out the legal is actually the slower part between those two things. But the reality is that one day for approval, instantaneous for access because of the cloud-based resources that support Kids First. Today, CBTN data is the largest cohort within the Kids First. It was the very first cohort within the Kids First architecture, in part thanks to the man who just walked in and will be speaking earlier, Warren Kibbe, who had actually been at the NCI when we first started, again highlighting that it was always a multi-institutional context that drove these efforts. To build that architecture, right, we couldn't just build it for brain tumors. We had to build it as an extensible framework. That narrative of connection and collaboration on behalf of the pediatric brain tumor setting in ways that's both self-serving but then extends impact to others will be a recurrent theme throughout the day, especially when it comes to the kinds of infrastructure and tools that we have to develop. When we were going to apply for the Kids First program to build that architecture, we had never built anything like that before. But there are a few who had, and Vincent Ferretti, who will come up here in a second to speak with me, is probably one of the most unrecognized culprits in developing the last 10 years worth of leading edge portals across the federal enterprise. And we had never met, and I flew up to meet with Vincent, and I pitched him the vision, anchoring it in CBTN, and really framing that the next wave of competition is going to be who can compete to share data, who can compete to connect data, completely reframe the architecture required to achieve what James just highlighted, right? One-day turnaround of access and use of data. To his credit, in Vincent's very quiet ways, which you'll see when he comes up here, he said, I think I want to do this. And he became part of our family, part of your family, in ways that is probably under-recognized. But Vincent and his team at St. Justine, a pediatric hospital across the border, are a critical component of everything we do and develop, and will continue to be as we go into ARPA-H, the Radiant Initiative, and more importantly, we'll build on that next wave of efforts that James hinted at, which is that clinical interface on behalf of that. So come up, Vincent, and I'm thrilled to have Vincent start, and then I'll take over a little bit after.
So thank you, Adam, for this nice introduction. So as Adam mentioned, we have divided this presentation in two parts. I will be giving the first one on the current Kids First portal and its limitations. And after that, Adam will take over with the second part on our vision for the next following years. So as of today, the Kids First Data Portal, the main role of the Kids First Data Portal is really to make the Kids First data set and biospecimen discoverable and access and available to researchers in secure compute environments. So, and just at looking at this number, we can see that Well, we need to be proud of that. We can say that we succeeded. We have succeeded. So the portal includes data from more than 35,000 participants now, from 35 studies, including the CBTN, of course. We store almost 500 data files, including images, such as MRI sky. We have a virtual biorepository of almost 150 biospecimen of different types, so blood, solid tissue, DNA, cell lines. And also, finally, we do have a database of 410 million of germline variants fully annotated. So the portal, what it does, it provides researchers with advanced interfaces to browse this data. And today I have only 10 minutes, so I will show you a few screenshots of these interfaces. And then after that, I will talk about the limitation where we want to go. So the first screenshot I have here is it's on our cohort builder. So the cohort builder enables researchers from build a virtual cohort of participants from multiple studies, thanks to our data harmonization efforts. So you have three sections in this tool. So on the left-hand side, you have a panel of search criteria or facet that can be used to formulate more or less complex queries that are shown in at the top right. And for example, a kind of query you can formulate is there any available gene fusion data for participants with astrocytic tumors? This is a simple query. Queries can be more complex. You can have more than one queries. You can combine them and so forth. And so we have the nice thing with this tool actually is that not only it finds the participant that match these criteria, but it will find also simultaneously their biospecimen and their data files. That's quite unique as a tool for searching data. So here you have the participant view, which is simply a list of a custom table of participants. Each row represents a participant. You see you have the Mondo diagnosis as a column, the HPO the phenotypes. And Mondo HPO are ontologies, so it's part of our data harmonization. So every phenotype, every diagnosis is named the same way, so you can search across studies the diagnosis and phenotypes actually. So once you get the result, you can save this list, you can save the filter for later use, and so forth. The second view, if you click on the tab, the biospecimen tab, you get the second view, which is what we call the virtual biospecimen repository. So this is a table of samples from multiple biobanks across the country used to generate the molecular data. So you can see here that our models support the sample lineage, which means that, for example, this DNA sample has been extracted from this specific tumor specimen. So we store this lineage. You see we have a long list of criteria related to biospecimen. Yeah. Also, each sample has availability status. So some samples are actually available, are made available from the biobanks for further experimentation. And the portal includes a tool that assists researchers in their preparation of their biospecimen requests. The third view is a data file view. So we just added the imaging data. So we launched this actually yesterday for this meeting because we know that imaging data is quite essential for CBTN. So we have created a series of facet or search criteria and columns for tables that are specifically tailored to imaging data. For example, you have a column here which is a link to Flywheel, so you can open this image directly to the Flywheel platform. So with this new facet, or specifically designed for imaging data, you can kind of build queries like find MRI scans, where the imaging technique used was perfusion for participant diagnosis with pituitary tumors. An important point is that we work closely with our partner to make sure that the portal is interoperable with their platforms. So by this, I mean especially Cavatica for the genomic data and Flywheel for the imaging data. So once you're happy with your file selection, you can push them to these environment and then start your analysis of the data. Finally, the last screenshot I have is it's on our Genome variant exploration tool. So in our database, as I mentioned, we have 410 million unique annotated variants. And our database in the Kids First is an aggregation of this of actually 447 billion variant occurrence. So it's huge. So a variant occurrence is a variant within a participant. So we have 447 billion such occurrence. We aggregate this to create and then the result is 10 million unique annotated variant. So it's quite complex as a pipeline to annotate the variant. I won't go into detail. We have in this interface 34 search criteria to search for these variants. And then, for example, as a query, you can identify rare pathogenic variants in gene associated with intellectual disability among Kids First participants. This character. Now, this is all good, but it's not enough. So the platform has its limitation, serious limitation, I would say. So first of all, we don't have access. There's no access to individual level genomic data. So we cannot answer a query like, does this tuberous sclerosis patient have a rare pathogenic mutation in this gene? We can't, because we don't have the variant at the individual level data. So we don't know this patient. We don't have the individual genome of each patient. The second quite important limitation is that our model still doesn't support longitudinal data. So which is quite important in cancer, actually. It's quite essential. So we cannot answer question like, you can read it, how do mutation in RB1 gene affect the risk of developing secondary tumor in survivors of retinoblastoma? We can't answer this question. There's no longitudinal view of the data. Another quite important limitation is the data ingestion. There's no real-time data ingestion at the moment. So ingesting new data in the portal can take hours or even days because it's done on per study basis. What we really would like to have, it's a near real time. As soon as the data come out from the sequencer, for example, we want to ingest it into the Kids First portal and then start using the platform to analyze this new genome that got ingested. So this is really our goal. Also, there's no integration with the EHR system. So the clinical data is prepared, massaged, and then imported into the Kids First portal, which is quite slow and limiting. And finally, there's no leverage so far of generative AI technologies in the portal. So user interface interaction with the portal is still primarily conducted through mouse clicks, and we want to improve this. So all this limitation really, if you want to take the Kids First platform to the next level, we really need to address this limitation. For example, this limitation, without this limitation, we would be able to implement a near real-time clinical genomic workflow, similar to the one my team is developing for the Quebec healthcare system. So Quebec has a public healthcare system, and they are integrating actively the clinical genomic in the system. And they adopted a model similar to Genome England or the one in France. So basically, the workflow we would like to have, I think, in Kids First, for sure, it's illustrated in this large blue box here. First of all, we deploy a central FHIR database. which store data from which is populate. Okay, so the FHIR database stored clinical data and metadata, sequencing metadata. The server is populated with data from various EHR systems, but they will be in coming next years replaced by a unique EHR system for all the Quebec. So there's a direct real-time connect. There will be a direct real-time connection between an EHR system and the central database for clinical genomic, which is this FHIR database. As once a sequencing run is completed, the data is immediately processed. So we run our genomic annotation pipeline that annotate variant based on the patient profile, the variant properties, literature, and so forth. And this is where the AI can play a very significant role, actually. So we annotate and we prioritize the variants. So then after that, all this result is stored in a knowledge base that is used by the geneticists to produce their clinical reports through a web interface, a web application. So you can see that this model is quite different than the current Kids First one. So it's real time, it's connected to EHR, and it's used in a clinical almost context, which we don't do currently in the Kids First. It's more a research platform than a clinical one. And if we want to have a real impact, I think we should move toward a clinical platform. Interestingly, in Quebec, actually, so for consented patient, data is copied also to a research environment. So to disseminate the data to the research, to make this data available to the research community. And this platform actually has a portal quite identical to the Kids First one, but for Quebec. So that's my last slide. That's Adam.
So hopefully you can see, how we're moving from, large scale cloud environments and tools, right, as supported by AWS in the cloud, to programmatic initiatives like the Kids First, to implementations, right, of solutions that we have been empowering on behalf of CBTN. And Vincent, again, skips over it a little bit quickly, but to our knowledge, right, the CBTN data is the only data of its kind that currently lives in a single portal where you can access genomic data, imaging data, the files themselves connected to cloud environments, connected to viewable derived data assets that you can request that data, get turnaround times in one day, right? Immediately act on it, create workspace environment for you and your friends to work on that data, and sets the stage for clinical impact in the coming days.
Right, but that's for the controlled access genomic data, and there's a tremendous amount of data that's valuable for analysis within 10 minutes, however it takes you to sign into the platform, despite the beauty of what Vincent showed as a future platform and all the negative stuff he had to say about the current things. That's unique. You can get in and look at a whole lot of data and come to some really nice conclusions and draw hypotheses now. So,
real quick, Adam, I just wanted to say the progress has been tremendous, and being able to spread the word is fantastic. I do think it's important. I've gotten a few messages from folks saying, what do you mean getting the EHR data is hard? So we take for granted knowing the labor of love, because everyone's like, Epic, Cerner, EHRs, it's digitized. I do think spending a minute saying, yes, folks, it's hard, and why this is needed, because I don't think everyone realizes outside of the community, the technology folks in the room have been saying, are you kidding? Why do they keep saying EHR data? We deal with EHR data all the time.
Yeah, I think it's a great point. And I mentioned that I was nervous at the beginning of the day, and I think that's one of the challenges, right, is to really highlight that, right, this moment in time where we've been building multiple work streams and they're coming together. What Ash is highlighting, all of us in this room knows that up until very recently, and still mostly today, the way we get data into these portals, the way there's 35 studies that are in Kids First, not just CBTN, all of them The way they got data from the EHR is a human copied and pasted that data from the EHR into a database. That is still the way 99% of research takes place. You can imagine that's difficult, expensive, and takes a long time. James is also highlighting something that I skip over, partly because we take it for granted. When the Kids First program started, the mental model of most NIH frameworks is all data sits behind a gate for human data. And thanks to really partnership with the NIH and the Kids First program, we created what's called a registered tier framework where you can get access to a ton of data before even engaging in genomic data research. And that's key because almost all of you, if you come to a portal, you don't actually begin with the question of which variant do I want. All of you start with a diagnosis of interest, a clinical feature of interest, or something along those lines. I mentioned there'll be several announcements today. The first is the Radiant ARPA-H initiative, which you'll hear more about. The second, and this is again a testament to true collaboration between the Kids First program, especially the NCI and partners at dbGaP, is that 2 days ago, we did our second release of Kids First data as part of CBTN. Jay mentioned this EXO-1 mechanism. We've been very fortunate as CBTN to receive genomic-focused EXO-1s. You'll hear more tomorrow about proteomic, metabolomic EXO-1 data. And so this was just released 2 days ago, and alongside with, again, the team's humble framework of loading imaging data, they just loaded all of that data into the portal and made it available. You know, it's one of the challenges, right? I get to stand up here and talk, but there's like an army of people working all day long to make this possible. When we started Kids First, to my knowledge, there was no public pediatric brain tumor cohort available. The very first cohort was the CBTN cohort when we launched Kids First with 935 participants in it. As of Monday, right, now there's almost 4,000 participants in there. You can see the samples that have been characterized from 2,800 to almost 8,200. But the last one is the important part because there's this exponential, as Roland mentioned, expansion of data. And you can see it went from 47,000 files to 255,000 files. This should give you a lens. This is just for CBTN, right? That should give you a lens on the challenge, right, that we start to face in this exponential framework. None of us can look at 255,000 files, right, in this context. For us, you know, this is a huge moment because we promised, right, to NIH and to our community that we would lead, right, compete to share. And partner. And so you can see that the PBTA, the Pediatric Brain Tumor Atlas, was not just CBTN on its own. It included partners from MyCosic and Carl Koshman, PNOC as an amazing partner in that effort, and several other initiatives, including Gift from a Child, Kentucky Registry, OligoNation, and NF2 Biosolutions, all partnering to advance this tremendous growth in brain tumors. In addition to just data size, there are several other firsts. This is the largest trio duo cohort today. That means that we don't just have tumor normal pairs. To my knowledge, for the first time, there are cohorts of parental samples paired with the tumor samples, setting the stage for what James and others have already hinted at, that there's a tremendous amount to learn from the germline context and the analysis there. It also contains the largest, to my knowledge, multi-sample autopsy cohort today, meaning that families and patients who contributed at the end of life, right, the entirety of their brain, and then we can analyze multiple parts of that tissue, compare it, understand the biological context that drove to the disease setting. And then the largest paired sample models, meaning cell lines and derived models that are paired with the original tissue in that context. So I have 30 seconds to set the stage for what I already had hinted at, which is the Radiant initiative. To date, I think our expertise has been in partnership and collaboration, and we've really, I think, excelled as CBTN to partner with all of these logos. And it's been really an amazing arc over the last more than 15 years of getting to this page. The fact that ARPA-H is the next context into this milieu really sets the stage for us to continue to collaborate and inform the portals, the platforms, and the real-time impact in that setting. With today's announcements and the press releases that I think are set to go in 1 minute online for the Radiance initiatives, there'll be a whole session about ARPA-H later today in the afternoon, where we'll dive more deeply into this next iteration that Vincent already set the stage for, and really to highlight somewhat Ash hinted at, which is the wave and challenge of these data workflows from electronic health records and the integration in more real time. So you'll hear a lot more about that for the rest of the day.